Okay, this is 7.1, number 68. Rocket accelerates by burning its onboard fuel, so its mass decreases with time. Suppose the initial mass of the rocket at liftoff is m. The fuel is consumed at a rate r, and the exhaust gases are ejected with constant velocity b sub c. A model for the velocity is given below, where g is acceleration due to gravity and t is not too large. T is time. So we are going to insert the values they've given us. 9.8 meters per second. Oops, that should be a negative then. Let's see. They don't. Oh yeah, they do tell us that the velocity of the gases that are being spewed out would be 3,000 meters per second. All right. And then natural log of the mass, initial mass, is 30,000 kilograms. Minus R, which is 160. R, by the way, is the rate at which fuel is consumed. 160 kilograms per second times t seconds. And divided by the mass, 30,000 kilograms. Okay. And the question is, find the height of the rocket 1 minute after liftoff. Well, remember, if velocity is given, then the integral of velocity will be the change in height. If you start at time 0, and times in seconds, it's implied because of the units here and the units there. So time 0 to time 60 seconds is just the difference in height from 60 down to 1. And sorry, this keeps jumping back and forth. I've recorded so many videos that my online space keeps telling me I'm out of space. It's not true, but I'll have to fix that. Anyway, that's what the integral of velocity gives us, is the change in height. So we just need to integrate this to find our change in height. So change in height from beginning to end will be the integral from 0 to 60 of this negative 9.8t minus 3,000. That is terribly annoying. Natural log of 30,000 minus 160t over 30,000. And dt. Okay. That should not happen anymore because I just turned it off. All right, integrate negative 9.8 times t squared over 2 from 0 to 60 minus 3,000 times the integral from 0 to 60 of the natural log of this number. I'm going to do a u sub here just because it would be beneficial. Let's see, negative 4.9 times 60 squared is what that will be. And in fact, I'll do a w sub because I'm going to end up using the letter u for our integration. So I'll let w equal 30,000 over 30,000, which is 1, minus 160t over 30,000. Then dw is going to be, let's see, 16 over 3,000 dt. I can reduce that further. They're both divisible by at least 2. Actually, technically, they're divisible by 4, but I do things by 2. So 8 over 1,500. which is the same thing as 4 over 750, which is the same thing as 2. I know I'm lengthy with this, right? 375. And that's as good as it gets. Okay. So dt will be traded out for 375 halves. And so we'll say minus 3,000. Oops, I already had the minus 3,000. So minus 3,000 times 375 halves integral. If t is equal to 0, we have 1. If t is equal to 60, oh, well, now I'm going to need a calculator. I think that's 8/25. Just did a little bit of arithmetic off to the side for that. And then let's see, natural log of u du. All right, or dw, I'm sorry. Natural log of w dw. Okay. Let's see. Again, I don't really have a calculator on me right now, so I'm going to keep these as exact. 3,600 at least. Minus 1,500 times 375. And now this integral of the natural log of w. So that is going to you're only able to do that by parts. You do not know the antiderivative of the natural log offhand, likely. So you need to, this is one of those rare circumstances where a by parts integration is necessary when you only have an integrand with one piece to it, one factor. So let's go ahead and talk about how we're going to do this. Remember, we're going to let u be the object that we can actually differentiate. Well, there really isn't an object here. U is the object we're going to differentiate, and dv is the object we're going to integrate. And there isn't anything here that I can integrate easily other than 1 dw. There is an object I can differentiate, which is the natural log of w. So if I'm saying things backwards, it's because it's like 6 o'clock in the morning, or 5 o'clock in the morning. My dog woke me up. So anyhow, du here is 1 over w dw. And v, if you integrate that, will be the antiderivative 1 is v dv. Or, I'm sorry, w dw. This is what happens early in the morning. Won't be a dw though. All right, so you can double check your work. Derivative of that v is going to be, the differential of that v is going to be dv is equal to 1 dw. So that does work out. All right, so we know that this is going to turn into uv minus integral of v du. So let's go ahead and write that in to our integral over here, times the group, u times v, which will be the natural log of w, times w, evaluated from 1 to 8/25, minus the integral from 1 to 8/25 of v du. So v here is w, and du is 1 over w dw. All right, so we have everything set up. And let's see, a negative 4.9 times 3,600, whatever that is, minus 1,500 times 375, whatever that is, times the quantity natural log of 8/25 times 8/25 minus the natural log of 1, which is 0, times 1. And then here the w's cancel. So if the antiderivative of 1 is just w, and we're evaluating that again from 1 to 8/25. Negative 4.9, 3,600 minus 1,500 times 375. You get the rest, right? There's not a huge point for me to write out all of this. Natural log 8/25 minus 8/25 plus 1. Okay. And then you would grab some type of calculator and figure out what that is. Roughly 14,844 meters.